Mabuhay everyone! Today I'm going to tell you about the process of photosynthesis. Photosynthesis is the process used by plants, algae, and certain bacteria to process energy from sunlight to chemical energy. The process of photosynthesis is divided in two parts: the light reactions and the light independent reactions. The light reaction begins when light is absorbed in photosynthesis 2 in the thylakoid membranes. The energy of the sunlight captured in the P680 reaction center causes the electrons from P680's chlorophyll to move to a higher sustainable level. These electrons pass through a series of cytochromes in the nearby transport system. After passing through the electron transport system, the energy-rich electrons lead to photosystem 1. Some of the energy in the electrons is used to pump across the thylakoid membranes. And this pumping sets potential for chemiosmosis. The spent electrons from P680 enters the P700 reaction center in photosystem 1. Sunlight activates the electrons, which receive a second boost out of the chlorophyll molecules. There they reach a high energy level. The electrons undergo a second transport system, but this time there is no proton pumping. Rather, the energy reduces NADP. This reduction occurs as two electrons join NADP and energize the molecule. Because NADP acquires negatively charged electrons, it attracts two positively charged protons to balance the charges. Consequently, the NADP molecule is reduced to NADPH. Electrons secured from water molecules replace these electrons. Each split water molecule releases two electrons. The split water molecules also release two protons that enter the cytoplasm near the thylakoid. The third product of the split water is oxygen. Two oxygen atoms combine with another to form molecular oxygen, which is given off as a byproduct of photosynthesis. It fills the atmosphere and is used by organisms. Now that we're done with light reactions, let's now move on to light-independent reactions. Glucose and other carbohydrates are synthesized in the carbon-fixing reaction, also known as the light-independent reactions, often called the Calvin cycle, after Melvin Calvin, who performed much in the biochemical research. In this reaction, an essential material is carbon dioxide, which is obtained from the atmosphere. After the carbon dioxide has been joined with ribulose triphosphate, a 6-carbon product forms, which immediately breaks in 3-phosphoglycerate. Each one converts into another organic compound. Only in the presence of ATP or adenosine triphosphate, the compound formed converts once more, using the energy present in NADPH.